Okay, we move on to a new topic now. This is a very important topic, and sometimes initially at least when people learn this for the first time, they struggle with the concept of conditional probability. Okay, so we're now looking at the conditional probability. So what is that? Often it is desirable to ask the following question: how likely is it an event A occurs given that the event B occurs? How likely is it that the event A occurs given that the event B occurs? Okay. In other words, given the partial information about the outcome of an experiment, so think of the event B as partial information. So given the partial information about the outcome of an experiment, what's the probability of an associated event? So you see, if you know that the event B has occurred, right? If you know that the event B has occurred and A is an associated event, then the probability of A, so we want to know what's the probability of A knowing that B has occurred. Does that make sense? Now, if I ask the probability of A, just the probability of A, all we know is that what we are asking is that what's the probability of A given that the sample space has occurred, right? Just the probability of A is basically the probability of A given that the sample space occurs, right? So now we're saying what's the probability of A given that B occurs? And let me explain this by using an example. So let's toss a coin twice, and I want to know what's the probability of getting two heads. What's the probability of getting two heads given that at least one head has occurred? Okay. Is everybody clear what the question is? So what's the sample space when you toss a coin twice? Well, we know that it is HH, HT, TH, TT, right? That's the sample space when you toss a coin twice. Let's let A be the event that two heads occur, and B be the event that at least one head occurs. Okay, so what is A? What is the event A? Well, the event A has only one outcome, right? HH. What's the event B? The event B is HH, HT, TH, and I shouldn't be including TT, right? So these are the events A and B. What's the unconditional probability of A? What's the overall probability of A, or the unconditional probability of A? The probability of A, notice, is simply 1 out of 4, right? I have a equally likely sample space. I have a sample space consisting of equally likely outcomes and a finite sample space, so the probability of A is the number of elements of A divided by the number of elements of the sample space, right? Which is 1 out of 4. Is everybody okay? Well, now what I really want to know is the following, though, right? I want to know what's the probability of getting 2 heads given that at least 1 head occurred, right? So I'm going to use this notation P of A given B. I'm going to read this as P of A given B. So this notation here will mean the probability of A given B I guess, let me say, perhaps better to say probability that A occurs given that B has occurred. Okay? So what should be the probability of A given B? Well, if you think about it, we are now given, so let's say you tossed, so let's say one of you have tossed the coin twice, and then you are telling me that at least one of them was a head. Okay? And now I want to answer what's the probability that I have 2 heads. So because I know that at least 1 head has occurred, right? I should be looking at the probability of A relative to the updated sample space B, because I know that B has occurred. I know the outcome is in B. I know that the outcome is in B, and I want to know what's the probability that the outcome is in A. Is that making sense? I know that I'm given the outcome is in B. What's the probability that the outcome is in A? Right, that's the question. And so this probability of A given B then should be the probability of A intersect B relative to the reduced sample space B. So notice the word reduced. So then what is that? Well, it is the number of elements in A intersect B divided by the number of elements of B, which is 1 out of 3. So notice that the probability of A, remember, was 1/4. Now the probability of A given B is 1/3. So the probability of A has increased given the information that I know now. Because I am told that B has occurred, the outcome is in B, so knowing that, the probability that the outcome is in A has increased, right? Is that making sense? So observe here, that the probability of A given B turns out to be greater than the probability of A. This is not always true, but in this case, that has happened. It may be that the probability of A given B is smaller than the probability of A. Is that making sense? Okay, so I'll see you on Wednesday.